Welcome to the DCD broadcast experience. Our 9 content channels are dedicated to helping the people who plan, build, operate, and supply digital infrastructure to make better decisions in a fast-moving business environment. Our interactive broadcasts, like the one you're about to watch, are part of a year-round program of fresh and original, always-on content that give you the chance to listen to the industry's leading experts as they dissect the latest technology and trends. By becoming a channel subscriber, you get unrestricted access to a huge content library of interviews, editorial features, ebooks, supplements, daily news and analysis, and hundreds of hours of on-demand broadcasts. You'll also get access to exclusive roundtables and the ability to connect to other channel subscribers. Oh, and no more signing in every time you want to view or download a resource. The Enterprise Data Center channel, the Markets and Investment channel, Management and Operations, Telecoms and Networks, the Edge Computing channel, the Energy and Sustainability channel, Critical Power, Data Center Cooling, and the Data Center Construction channel. We've got it all covered. Whether you're a procurement professional or a design engineer, a CEO or an operations manager, our mission is to keep you informed and connected, because the world depends on digital infrastructure.
Hello and welcome to the Towards Net Zero APAC broadcast. I'm Alex Dickins, Channel Management Team Lead at DCD, and I'm delighted to welcome you to the latest series in the Energy and Sustainability channel. Over the next 2 days, we look forward to exploring how APAC's digital infrastructure providers are building sustainability into their planning and operations. To kick off this series, we'll be hearing from Freddy Briffitt, Sales Manager for EMEA and APAC at USystems, who will be exploring how data centers can leverage air-assisted cooling to drive new efficiencies at scale in this broadcast sponsored by Legrand. Now, without further ado, I'll hand over to Freddy, who'll be presenting a brief presentation before we go into Q&A.
Good afternoon, everybody. Thank you for joining. We are Legrand. We're a global manufacturer established in over 90 countries, and we sell to over 180 countries. And we produce leading technology with a focus on improving people's lives. Now, to tell you a little bit more about me, my name is Freddy Briffitt. I've been with USystems since 2018 when we were a privately owned business, so that's 5 years. I personally am a massive fan of technology, so it's a pleasure to be able to do what I love and be able to present this technology overview to you guys today. So I'm actually going to start this presentation off rather than talking about the how of what we do and what it is we do specifically, but to talk to you actually about our core beliefs and values as a business. So it's important when you are an organization as big as we are, as big as Legrand, that we have an overarching company-wide focus. That every day, regardless of what we're doing, be it within a data center or in our offices or our home offices, that we always remember these core values. And really, the technology that I'm going to talk to you about today really lends itself to a few of these values. So we came up with our CSR, corporate social responsibility. There are 4 pillars with it that you can see on the screen. And today specifically, we're going to be focusing on how we can reduce our carbon footprint. And also help our customers reduce their carbon footprint. So I wanted to talk to you a little bit more about USystems, because I'm sure most people will know about Legrand as a brand. You've probably seen us anywhere from your household plug socket to your data center, but USystems you may not have heard of. So we were a privately owned business up until the summer of last year, and we're based. The factory was based in the UK, although we had sales globally. And really, we're lucky because we were a business that was driven by innovation and really listening to our customers. We had some really, really close relationships. So the products that we've got today have really, we've really listened to our customers and what they have to say. Becoming part of Legrand was brilliant for us because we actually share a lot of the values and a lot of the material that we have on carbon emissions and reduction of was there before we were acquired. So it's not like it's something new to us as a business. So before, again, I start talking about the technology specifically, I really want to focus on why. why are we being asked for higher densities per cabinet? Why is this important to us? So AI and IoT are buzzwords that we hear every single day in our industry, but AI, artificial intelligence, is becoming more and more a part of our day-to-day lives. And I think certainly sometimes even I don't realize how accustomed I've become to using AI. I can see to the screen on the left of me that Teams is actually transcribing what I'm saying. So it's listening to my voice, converting that to text, and there's no human behind that. That's being done by a processor on a server somewhere. More and more things are becoming connected to the internet. I'm actually in my home office today, and my dog, who you can perhaps hear tapping around behind me on the wooden floor, he has a collar that's connected to the internet, so I can see where he is if he ever, God forbid, gets out the back gate, and my wife goes crazy. Or my vacuum cleaner is connected to the internet. It's a little self-contained robot Hoover, as we call it in the UK. And we're so accustomed to having devices that connect to the internet. I, for one, as soon as a page doesn't load or I have any sort of buffering, absolutely lose my mind. And data center operators need to be able to service equipment that is servicing our ever increasing demand on applications that rely on AI. And they need to do this in a way that still maintains efficiency. There's a massive spotlight, as we all know, on data centers to become more efficient. So they're really, in my opinion, at a crossroads. How do we provide higher densities per rack while still maintaining an efficient environment? So ultimately, to cool a data center, you need some sort of medium, be that a refrigerant gas or chilled water. And the maximum impact on efficiency on the cooling side of things is ultimately how cold or warm this medium is. Now, we're going to focus on water for this particular discussion. And the specific heat capacity of water is massive. It takes a massive amount of energy to change the temperature of water, be that up or down. So data center providers with traditional cooling, the supply to the CRA units is normally quite cool comparatively. So there needs to be a big amount of energy inputted into the system to be able to do this. And as the density per rack increases, cooling with just air alone becomes a problem, and data center managers need to look at methods to help work around this. So how do we help? So we brand ourselves as air-assisted liquid cooling. Now, if we get the technical manual out, to be very, very clear, USystems is most definitely air cooling. We don't have any liquid on the GPU or the server itself. We're simply passing air over the components. But what we do have is we have a rear door that has a coil of warm water in it. You can see the pipework connections to it at the bottom of the screen there. And we have our liquid very, very close to the source of the heat. So when I said to you earlier that the energy required to change the state of water is massive, ultimately the closer we can get the water to the heat source, i.e. the servers, the less state change we have to have within, or temperature change, sorry, we have within the water itself, which means the equipment behind that is working less hard, which really helps reduce the overall power. So to talk to you a little bit more detail about how it works, we've got four main components. So we have a frame that enables us to mount the door onto the rack. So these are vendor neutral and they're retrofittable. We then have a coil of warm water, like the radiator in your car, but with water, that's mounted within the door itself. So it still functions like a normal cabinet door. And then we have the fans. So we pull the air on most of the models of our rear door over the coil. And then we have the management system. So the CMS, cold logic management system, which monitors what's going on at the back of the rack, what's going on in the room, and then modulates the temperature depending on this. You can see, you've seen from the picture before, we connect to the main building water supply via two flexible hoses that have got 37 layers of silicone, and can be either top fed or bottom fed. And then we also have a valve which enables us to control the flow of the water. As I said, typically when we're working with customers that are building new data centers, they end up putting the racks and rear door coolers directly on the slab because it saves the need of putting a false floor in. However, some of our customers have got legacy false floors and they prefer to do the pipe work under the floor. So it's flexible in either ways. We have a couple of different models throughout the range. So I'm actually going to start with the CL20 and the CL23. So that's the central image and the image on the right-hand side of the screen. So the CL20 is an active rear door. And by active, that means it has fans that pull the air over the coil itself. Now, the CL20 is capable of up to 92 kilowatts, and that's sensible cooling. So that's where our supply water is above 14 degrees, so we don't have to worry about humidity, sorry, condensation. And although it says 92 kilowatts, that's the max it can do. Really, if we have customers that are at 10, 15, 20 kilowatts, we can do that, and we can do that really, really efficiently. So the less kilowatt cooling we have, the more efficient the door runs, and the warmer the water is. So that services 90% of our customers. We then have the CL23, which is just a larger XL version of the CL20. So it's a bigger door, it's thicker, it's got more fans. And this was actually produced for one of our bigger customers that has got 140 kilowatts per rack. They were looking at liquid on-chip cooling systems, and they said, hey guys, what can you produce? Because actually our GPU isn't that hot. And we, got our technical team together, got on the whiteboard, and this is what we came up with. That's been deployed in their labs. And then finally, we have the passive. So the passive door itself, as you can see, is simply a coil. It doesn't have fans. The passive door itself relies on the servers within the rack being able to produce enough static pressure to push the air over the coil. Now, that's okay if you can guarantee the airflow from the back of your servers. We have some customers that have got some older servers that they're deploying on a rollout that has exactly the same airflow every single rack. And ultimately, if we only have to run one set of fans, it's going to be more efficient than running two sets of fans. So that works really well for them. But for most of our customers, we recommend an active door because the newer servers, the newer fan sets that have come out don't necessarily produce enough static pressure to push that air over the coil. So that's how we do what we do, but what benefits does that bring? So there's operational efficiency. So because we're so close to the back of the active equipment, we can utilize really, really warm water. So we can use typically a 20-30 flow and return, which will enable us to benefit from free cooling. And it also means that our fans are working not as hard as the fans on equipment that's not as close to the source of the heat. So our power draw is really, really low, and we have a fantastic EER. As I said, we're retrofittable, so we can really help in data centers that have got power, but they haven't got cooling. They run out of cooling, so it works really well. We also see a space saving as well. Obviously, that's going to be dependent on site. So the rear door actually, because we don't have to leave as much room for maintenance, can see an increase in the number of racks we can get in the room. As I said, we have a significant reduction in CO2 because we're not necessarily running a chiller or a compressor on the plant on the outside that services the rear doors. We can do it with free cooling. And we see a significant up to 100% water saving because we can operate a closed loop system where we're just pumping the water back around the system. Now, how does this help you? We wanted to do some specific numbers, and if you're watching this and you're thinking, hey, this could really potentially be of interest to us, but how do I monetize that when I'm talking to the business? Well, we can help you with that. We've got the calculations behind this document here, and we can do it specifically for sites. But what we did here, we looked at a 2 megawatt site, and we looked at 8 to 10 kilowatts per rack. We compared to a traditional, air handling unit based system with our containment versus our RID. So not massively high density. We could go higher, but this really is for us the sweet spot of when's it appropriate to start looking at this technology. So we saw that we'd give N+3 in the fans. We'd give A and B power switching at rack level, so there's an element of better redundancy there. We worked on a 29-degree flow and return, so that means we can get free cooling, and the power usage on the fans at the door level was 159 watts for the 8 kilowatts and 180 watts for the 10 kilowatts. So a really, really good ER. And we also saw a 40% reduction in footprint overall. So what does this mean for the business? Because we're using warmer water, we don't need to run a compressor. And because our fans are drawing a really small amount of power, we could actually save this customer $472,000 a year. That also helped reduce carbon emissions because of the electricity we weren't using by 550 tons per year, which is the equivalent of planting 90,000 trees, which is the equivalent of covering a quarter of central London in trees. So, I think that graphic on the right really shows it so well. That's such a big area that would have, otherwise been put into the atmosphere as carbon dioxide, which, as we all know, is not good for the ozone layer. So, to summarize, we're branding ourselves as air-assisted liquid cooling. So we're giving you air cooling, but the benefits of liquid cooling. We can increase the density per rack. We can help with the amount of power draw being done, and we can, overall totally change the dynamic of the data center. I just wanted to talk to you about a real world example. So Cambridge University's data center, it's 1.2 megawatts, and they have free cooling year round. They don't have any compressors on site. They've got a range of rack densities from low to high density. And the PUE on their cooling is phenomenal, 1.035. That site's been running for a number of years. It's close to our factory, and we're very, very lucky to have been involved on a project that really can showcase what we're capable of. Thank you very much. Are there any questions?
Well, thank you very much for that presentation, Freddie. It was really insightful. So before we jump into the Q&A, we would like to quickly share a slide around USystems' first deployment in Singapore, as well as a short video around what USystems can offer.
The demand for high-speed data and data storage continues to grow at pace, whether stored in the cloud or locally on the edge. It's anticipated with 5G and IoT, this demand will increase 20-fold in the next 4 years. And housing all this technology and innovation is a growing mix of hyperscale, large, and micro data centers, each supporting the internet at every level. The trouble is, most data center designs are bad for the environment. On average, they squander nearly half a gallon of drinkable water for every kilowatt hour of power used. By 2025, U.S. data center consumption alone will top 100 billion kilowatt hours. That is the equivalent of 588 coal-fired power plants. And of all the electricity used, up to 38% doesn't even power the IT equipment. Instead, it's used just for cooling the data center. And this is totally avoidable. The reason for this? Unbelievably, some data centers deployed today are still using outdated 30-year-old technology and data center designs. Whilst there have been minor bolt-on improvements to address cooling issues, such as aisle containment and HD air vent tiles, these are driven mainly by the need to bring more power to the rack, and not for environmental reasons. When these solutions don't work, DC managers are forced to remove or spread racks to increase air volume, wasting valuable real estate, just so that the cooling technology can keep up. If this isn't bad enough, server manufacturers are now launching hardware capable of up to 5 kilowatts of IT load per 1 unit of rack space. The truth is, none of these workarounds offer any long-term viable solution to a situation fast reaching crisis point. It's time to stop, pause, and think. It's time to reset and seek a new approach to data center cooling. We are USystems. We challenge the conventional and rewrite the rules. For more than a decade, our innovative designs and solutions are core to some of the most energy-efficient data centers on the planet. Established in 2004, Our multi-award-winning cooling technology has been helping data centers become more adaptable, resilient, and energy and water efficient in response to the continuing rise in data consumption. As a company, we consider our customers and suppliers as partners. Our mission is to help data centers reduce their carbon footprint, water waste, capital expenditure, and minimize the use of harmful refrigerants. We are inspired to work with like-minded people, those who are committed to making positive change, those who do business the right way for the planet and everything on it. Are you ready to make a difference?
I now want to take some time to ask some questions to our audience. If you do have any queries, please submit them now in the Q&A widget on the bottom right-hand side of your screen, and we'll do our best to address them all. So, Freddie, first question to you. Can you give any examples of other unique projects USystems has worked on?
Yeah, absolutely. We have a really interesting customer in the UK, a company called DSM. You can find them on LinkedIn and online. They're trying to build a small sustainable co-location using our rear doors. And what the guys there have actually done, Mike and Helen, hello, by the way, guys, I know they'll hopefully be listening to this. They've actually dug a lake, a small lake, and they've sunk in the lake heat exchangers. And what they're doing is they're pumping the water from the data center through the heat exchangers, and they're actually using that lake to take the heat out of the water, and then it's pumped back into the data center. So super efficient. They've got chillers on site as a backup, but the primal cooling circuit will be done with the lake. And it's really nice what they've done there. They've actually kind of made a bit of like a feature of it, so it doesn't look like, you know, a body of water with some metal in it. They've landscaped it. It's going to be quite a nice place because customers will be able to come and see the colo facility, do their work on the servers, and then take a nice little walk to the lake where they've got some picnic benches and stuff. And yeah, it's really cool actually.
Okay, fantastic. And just a kind of part two question. As you were mentioning, you know, kind of proximity to the lake. Surely site selection has to come into the decision-making process there. You know, have you got any other examples beyond, you know, just systems sort of located near to lakes? Are there any other cases you can think of?
Yeah, so we have a great case study on our website with Georgia Tech. And DataBank. So they actually, it's in Atlanta in North America, right in the city center. They've really cleverly thought about their facility. There's a good tour online. I won't go into the details of it because the tour does it way more justice. I'm sure we can maybe share a link to that in like the follow-on for this. But yeah, that's another really good example. Another interesting customer of ours is Nautilus Data Technology. So I'm sure most people listening to this would have heard of, where they are building data centers on barges, taking water from that body of water that the barge is in, running through, using cold logic, cooling the data center, giving high densities, but not having a massive impact on the environment.
Okay, fantastic. And to stay on the subject of location, could you speak a bit more broadly about how many deployments you have globally and which locations you operate in primarily?
Yeah, so although USystems up until last year was a privately owned, fairly small business, we actually have historically had deployments all over the globe. A lot of our customers operate out of North America. A lot of the bigger technology giants that we all know and use every day. We also have quite a few deployments in APAC itself. So some really good customers in the Middle East. We've got some good case studies on our website. I think the beauty of Cold Logic is that because we're able to give customers high density cooling with warmer water in climates where the ambient temperature is elevated, and it's more humid, the plant on the outside is working way less hard than it would be with, say, a traditional cooling method. So yeah, flexibility all over the place. We actually currently have 9,000 rear doors deployed globally that are running. We did have a calculation at one point as to how many megawatts that was, and I have totally forgotten it, but it was a decent size. And the original site was back in 2007, still running today. So yeah, hopefully that answers that.
Fantastic, thank you. And to speak a bit more about your customers, have you got any examples of any use cases there where customers are deploying ColdLogic and what exactly they're doing?
Yeah, definitely. I think that's always been something that's really interesting to me, because I know a lot of people that will be watching this are the same, that you'll go into a data center, it all has the same sort of generic corridors, and a server looks like a server with some flashing lights on the front. But actually, it's always really interesting to me to understand what the real world impact of that compute is. So we have some customers, to name a few, that I think I'm actually quite proud of, that are in sort of the medical research space. So one of our customers is really big on genome sequencing, looking for some solutions to some of like the biggest health issues that we face in 2023. Crunching that data, looking at the different makeup of the DNA helix. I'm going back to my sort of school understanding of chemistry here, but really, really interesting. We also have some customers in like the financial industry that are using HPC for risk analysis. So they're looking for either fraudulent transactions or perhaps transactions with embargoed countries that the bank's going to face fines if they're trading with by accident. So they run these algorithms, they scan loads and loads of data, and they look for particular repetitions and patterns, and say, actually, hang on, this is potentially an issue, and then that flags it for someone to have a look at, to name a couple. I'm sure there's loads more than that. That's all I can think of right now.
Brilliant. Yeah. I think a couple of good examples, given that we put you on the spot there. Also, just a reminder to our audience, we've got a couple of questions which have come in, but please do keep submitting them. This is a bit of a future gazing question, but I guess it ties in with the kind of applications and the kind of densification of chips. But do you think that the maximum density per rack will ever peak?
Well, I think it has to. With technology the way it is at the moment, we are at the mercy of the laws of physics, and there's only so much power that you can cram into a rack. However, having said that, when you look at that innovation over time, when you look at, say, the technology they had to send the space shuttle to the moon, on my desk right now, I've got a phone that's thousands of times more powerful than that and can do way more things. And I always think, if you said to even my granddad, bless him, when he was about that, on this little computer on your wrist, you can speak to my cousin that lives in Germany with a touch of a button, he'd be like, no, this isn't Star Wars, this isn't sci-fi. But actually, today that feels really normal to do that. So yeah, I'm sure there will be a point at which the way that we see data centers today, there will be a cap, and you physically can't get any more power to that rack. I think the cooling is probably a little bit further ahead of the curve. But then, having said that, who knows what data centers will look like when we're all dead and gone, and they're a historic thing of the past, maybe.
Mm-hmm. Yeah. But to talk about kind of fitting, more compute in more space, what about footprint when it comes to adding a rear door? Is it going to take up more space in your data center?
Yeah, so I think that question's a little bit subjective. And obviously, every single site's going to be different, and it's going to depend on the overall needs of the business. Because sometimes, I think in certainly our literature and stuff, we always think absolute best case. So there is probably perhaps a little bit of bias there. But I find in most cases, you can typically fit more racks in the white space, and you can also fit more compute in those racks. Although the rear door runs between 250 and 380 mil onto the back of the rack, the actual space for the maintenance is significantly less than that of, like, let's say, a traditional air handling unit. So yeah, it is, as a salesman, I want to say, yeah, you're always going to fit more rear doors in the space. But if I'm being totally honest, it's going to be dependent on the site and how that works. Hopefully my boss won't hear this.
Brilliant, thank you. So just to kind of move the conversation along a little bit, I'd like to talk a bit more about, the infrastructure and how data centers can adapt to implement new technology. So, you know, can we spend a bit of time talking about the retrofit and retrofitability of this product, which you alluded to during the presentation? You know, how easy is this to embed into existing infrastructure? I guess it's a very different story for brownfield versus greenfield sites.
Yeah, so in terms of actually physically mounting the door itself on a rack, super simple. So as I said in the presentation, we have that standard interface frame, and then we mount that onto a pre-existing cabinet with a specific bracket set. So it doesn't matter if it's not a Legrand cabinet, you know, if there's a legacy one, another vendor, no problem. Chances are, over the years, we've probably already done a fixings kit for that rack, but if not, we just need to either have some measurements or some CAD files, and we can knock something up fairly quickly. Then really, the next element is on that mechanical side. How do you physically get the water to that rack? And of course, that's always going to be a bit of a challenge. And I think it's one of those considerations that when a data center is going to depend on, is this a specific customer that they are, it's a colo bidding that space for, or if it's not a colo, is this a refresh, and how's that going to work? Realistically, I think you need to have a main pipe header running in the white space to be able to tap off of for the individual rear doors. So that's probably the biggest challenge. Having said that, you know, it's not beyond the realms of possibility. A lot of our legacy sites that we work on have pre-existing raised floors that are empty, which are not needed anymore because we're not using that for the plenum. We're using the rear door for that. So, you know, we can fit pipe work under there. But yeah, obviously, depending on the size of the data center, it's a decent change, but yeah, not earth-shattering to do.
Brilliant, thank you. But obviously, with you know, retrofitability comes serviceability. Can you speak about how serviceable the tech is?
Yeah, so you know, one of my colleagues used to describe this really well. Ultimately, the door doesn't really have that many moving parts. So if you imagine for us in the UK, the heating systems in our houses, or for those further afield, HVAC systems, as long as you don't have a massively too high flow, which will help to make sure the flow is within an allowable limit for the coil. The coils are fairly maintenance free. And then the fans themselves are hot swappable. Another one of my colleagues, so I'm sure he won't mind me saying this, Gary, if you're listening, hello mate, was actually, has changed the fan after being at USystems for 1 or 2 weeks. Not saying Gary isn't capable with a screwdriver, but you know, it's a really simple process to do. So yeah, maintenance-wise, fairly limited, not many moving parts, very well made as well, which also makes a big difference.
Brilliant, thank you very much. So we're obviously talking a lot around, you know, water, you know, being used to cool a data center, kind of does what it says on the tin with liquid cooling. But you know, maybe, you know, the elephant in the room would be the question: is water in a data center actually safe?
Yeah, good question. One we're asked on a regular basis. Obviously, water and electricity don't mix, and data centers have a lot of power in them, as we all know. Water in a data center, it's not a new concept. If you look back at the original IBM mainframe, they were water cooled. The key, as with anything, you know, when you're putting high power into a rack, is that there needs to be standards, so it's done safely, and it needs to be done by a competent, qualified engineer from point of install all the way back to the consultant specifying the products that are going into it. So, you know, provided the installation and the design are done correctly, that, you know, there shouldn't be problems. Data centers already have water in them for the cooling systems. It's just the proximity of that to the equipment that is different in our case. As I said earlier, you know, we've got thousands of rear doors that are running, and they've been running for a number of years without issues. So yeah.
Brilliant, thank you. And you know, just to stay on the subject of water on fluids, you know, what coolant fluids is your technology compatible with?
Yeah, so we work with chilled water. We don't offer a DX-based system in ColdLogic because we have issues with condensation given how close we are to the back of the active equipment. Sometimes, depending on the ambient temperature outside, we'll have a glycol mix in there to just prevent the system from freezing. But yeah, simple as water.
Brilliant. Yeah, well, they say simple solutions are the best solutions. We are running out the clock, but I've got kind of a really good question. And I think we could spend a long time talking about it, but I'll let you try and get through it in a couple of minutes. But would you say your rear door is more effective than liquid cooling, be it on chip or immersion?
Yeah, it's a good question. Obviously, I'm going to say yes, because that's my job. But I think, again, really, it's going to come down to the customer's needs and, more importantly, what active equipment's inside the rack itself. For me, on-chip cooling is really, really interesting because there is a point at which, being totally honest and transparent, that GPU gets so hot, you physically can't pass enough air over it. So, although our door, the CL20 can go up to 92 kilowatts and the CL23 can do 200 kilowatts, as the density starts to increase, naturally that GPU gets hotter and hotter and hotter. What I think is a really good solution is a system that deploys on-chip cooling with our rear door, and they work tandem in hand. I also think immersion cooling has its place, but obviously there are some distinct differences between an immersion tank and our rear door in terms of the weight of the system, the cost of the system, the footprint it takes up. But yeah, I think for me, it's a difficult one to say which is better because it's going to depend on what you've got inside your rack. And I think it's important that when you look at deploying your data center, you take all aspects into consideration. It's a real challenge nowadays to be able to deploy a data center that can service high density, but still not lose the importance of the efficiency. And I think looking at multiple technologies and how you can deploy them together in the most efficient way really does make sense.
Brilliant, thank you. Well, I think that brings us to the end of the time we have. But Freddie, thank you for tackling all those questions, and for the presentation. It was really great to hear from you, and thank you to Legrand for sponsoring.
Brilliant, and thank you too, and thanks everyone that watched. I hope it was worthwhile.
Excellent, thank you. A reminder, if you did miss anything, the session will be available on demand shortly. The next session in the programme will be taking place at the top of the hour, and we'll explore the topic, is the rising tide of sustainability standards even applicable in the Asia Pacific? An interesting session for sure, so we'll see you in a few minutes. Thank you very much. Well, that was great. Now on to the Q&A.